Hi guys, you're welcome to my channel. Today we are going to discuss about process operation for conveyor system. Okay, like I always advise that you should understand the concepts of design. Okay, you should have design skill when you are coming into automation space. You should also understand logic principles of operation before you write a program for PLC skill. All right. So for better understanding, today we are going to discuss about operation sequence of a conveyor. Okay, but we are going to design first. We are going to go into designing the logic. All right. So why I always advise my student and I always train them for designing before we write a program. Whenever I want to design any sequence operation of a particular task, first of all, start with design. So design will enable you to know the operation sequence of that particular design. We also understand the troubleshooting approach and also understand when the system is due for upgrading or for alteration. Okay, so if you understand how to design, you should be able to know how to also execute a particular design that is putting up by someone else. Okay, somebody can put a design and give to you, hand over to you to execute. So that is the advantage of you having the design concept and have that knowledge before you go into automation. And if you have that design skill, whenever a program is having an error, you can also change that particular logic, all right? Because you know the operation sequence, so you know what you need to add and what you need to subtract to make the system work, all right? Okay, so but now we are going to design this particular logic operation in two different methods. Method one, we are going to design this logic for schematic, control schematic, and also simulate it with control schematic using control software. Then the second method, we're going to write a program. We're going to open PLC software, all right, automation software. We're going to open Siemens Tier Portal software and write the program and also simulate the program there. Okay, all right. So it's always a good practice for you to understand design. All right, you must design. Design will enable you to know where you are coming from and where you are going to. Okay, so let's bring our narrative for the design. Let's go to our narrative. So this is our narrative. Okay, this is a process operation for conveyor system. I will also walk you through one particular simulation for conveyor with a pneumatic system. But this design does not include pneumatic. We are going to design a simple program logic that will control a conveyor, and we are going to integrate the program with a counter and a sensor and a timer. These are major components that is required to put up this design. So before I read this narrative, let me just walk you through the operation sequence verbally. Now, this particular logic is going to be designed such that when the process is initiated, then the finished product is going to be a factory producing an item. Maybe you are producing a product. So this conveyor is going to be moving on a circular method. It's going to be moving 360 circular. So now it will be going rotational that way. Then we have a lot of other items, other machineries within that same factory setup for different to perform different tasks. But we are going to concentrate on two major sensors, counting sensor and two major sensors. One is for counting of number of product produced, the total product that is going to be produced per day or per operation. Then another sensor again is going to be responsible for counting number of product per batch. Number of, for example, you have a batch, you have a set, a dozen to produce. You want to produce, for instance, produce 12 or 24 or 50 that make a set or make a dozen. So there is two sensors that will take care of that counting of that particular set of product. All right. So you also know how to use sensor in a program, in a logic. Also know how to learn how to use counter to count number of items that you produced. Okay. They're going to also use timer. Timer is to enable us to give a break, a hold on for a particular set to be completed before another sequence will commence. So that is the reason why we are integrating a timer. All right, so this is our narrative. Network one is going to be designed such that when the process is initiated, is activated, a conveyor system is going to be energized, and that same process, that same network will be latched. Network one is responsible for activating our conveyor and also lashing logic. Okay, that is for network one. So network two is responsible for a product counter sensor will be there for counting the number of product that we are producing. Also counting the number of finished product that is going to be stored in the warehouse. Okay, so that is for network two. Network two, let me read it now. Product counter sensor start counting immediately when an item is detected. Okay, when the items are moving along the conveyor, the sensor will detect the presence of that item. Immediately, it will shut down conveyor. Okay, it will shut down conveyor and the activate timer network. These three network. Network one is responsible for initiating the process and also putting on conveyor. Network two is responsible for counting number of products and also controlling the movement of the conveyor. That is for network two. Okay. If a particular badge, if you are counting 20 make a badge or 50 make a set or make a dozen. So this sensor, this particular sensor, this product counting sensor will be sensing the movement of that product. Once the number of the item is completed, this particular sensor will send signal to a counter. Then a counter will shut down conveyor on temporarily, then activate timer simultaneously. Once it shut down conveyor, it will activate timer immediately. So timer will hold on. There is going to be another machine, but it's not included in this design. That holding time of timer is to enable another machine to pack out to evacuate that set of dozen or set of produced uh, finished item for a while. Then another sequence of counting another dozen will commence again. Okay, so that is for this network, right? We're going to add another network, but that network is going to be another counter. This counter is responsible for counting number of items per badge or per dozen. So we're going to insert another network, making network 4. We're going to insert another one. That network 4, we're going to introduce another counter to count the total number of finished product produced per each operation or per day. That is, that particular counting will be counting as soon as you initiate the operation, the counting will start. So it's going to be a cumulative finished product counted. Meanwhile, this particular one is going to count only per set. It's going to be counting per dozen. Each dozen completed, the conveyor is going to be on hold, then timer will start. Then that particular set will be conveyed or move out by another machine to another location. Then another set of dozen will start producing, will start counting again. Okay, that is this counter. So why this one is counting per badge or per dozen, I want another counter again that will register the total number produced. Like if I produce like for instance, I produce each pallet contain 50 bottles per pallet. 50 bottles make one pallet, for instance. Now this one will count how many pallets per each sequence. Each sequence operation will be equal to one pallet. Two sequence is going to be two pallet. three sequence is going to be three pallet. That is what this counter will count. But I need another counter that will take inventory of the total number of the pallet produced per each operation. So if I produce 50 pallet, it's going to be 50 times 5. Okay, all right, or it's going to be 50 times 50. All right, so if 50 make one pallet and I produce that 50 times 50 times, so another counter is going to be inserted there to take the inventory of how many total for the whole operation. Meanwhile, this one will record how many per each pallet. Okay, because it's going to be wrapped and pushed to another warehouse, something of that nature. Okay, all right, so now that is the narrative. So let's go back to the design software to where we do the design. Okay, all right, before we commence this particular design, I always agitate that my student must understand design structure. You must understand how to design. When you understand design, you can now write a program to control your logic. Okay, all right, so let me show you the video. Let me show you a video where you understand the operation sequence of what I just explained now before we now go into the design proper. Okay, so let's watch this particular video. Before then, let me explain the operation of this. Okay, let me explain this. Now look at this conveyor now. This is a finished product moving along this conveyor. There's another conveyor this other direction here. We have two conveyor. One is going this horizontal side, one is going on vertical side. Okay, now when this finished product move to this point, there's going to be a pusher device. There is a pusher here designed with a pneumatic structure using pneumatic method. So we are going to use this pneumatic method to push three items out of this line of product, push this three item go to this direction, because it's going to be shifted to another direction where another machine is going to process, add more infert to this. Okay, so the work of this conveyor, this one, is to convert the whole of this finished product to this spot. Then the work of this pusher is to select tray and push towards this direction. You'll be pushing tray one after the other, going front and back, front and back. You'll be moving them according to tray, because the size, the width of this conveyor can only accommodate tray. So that is why this pusher is taking tray only at a time and come back to take another tray, come back and take another tray. So this tray, they will line up this way. And that is because if they want to wrap this product, it's going to line up as a tray to go into the carton. So that is the lining stacking order. Stacking order of this product is going to be tray per line. That is why this conveyor is designed such that only tray can accommodate this width, can only accommodate tray, because this tray is going into a carton with this order. So that is the arrangement. Okay, so but because this other one, they are coming in numbers. Okay, this one is coming from another direction, but when you come to this direction, it's going to the finishing process point where this one will be stacked in a carton and wrapped and moved to warehouse. So that is the reason why this pusher can only move tray, because this tray is going to be aligned with this order right inside the carton. Now, the idea now is that this pusher will now push tray, and while this pusher is pushing tray to this direction, this other one is going to be on hold. That means before this pusher push this product to this direction, conveyor will first of all stop. This one will first of all stop and be on standstill. Remember I told you that there is going to be a timer in our design. The essence of that timer is similar like this, is something similar to this I just explained. For this one to come here and stop, there is a timer that will make that move to stop. Not timer, there is a sensor that will stop this movement. Okay, it can be timer together with a sensor to work this, or whichever configuration that is going to be integrated to that logic, but the end result is that this item must stop here. Okay, to enable this pusher to select tray and move. And when it come back, before coming back, when it's coming back, this other one will move again to line up tray again. Then it will come back again. Now there's a sensor here. There's a proximity sensor here facing this direction to sense the distance between this finished product and where it's going to be situated. So this sensor is the one responsible to shut down this conveyor, to ask this sensor conveyor to put on hold. Why this pusher? Once this sensor stop this, that same sensor will activate this pneumatic system to push. So this sensor does two functions. One is to stop the movement of the bottle. Another one is to activate the pusher from this pneumatic system. Okay, you now understand the logic. So let me simulate it now. All right, look at it. Look at how it's moving tray, only tray can move. Okay, all right. You see, it's in a hood. Okay, just wash. All right. Okay, so that is the similar design that I want us to do. So we're going to design similar. Look at this bucket sensor. This is proximity sensor sensing the distance between this point to these bottles. So once the distance between these three, once this sensor senses three lining up here, it will now stop. Once he asks this conveyor to stop, he will now immediately ask this other pneumatic pusher to get activated. And this pusher will now push. Once he pushes in, then going back again, we reactivate this to come back so that when you are coming back, you also meet another three again coming to this area. Okay, so that is why I want us to observe the operation of this, because what we are going to design now is something similar to this, but not exactly this, but the same operation method. Okay, all right. So if you take a look at this area, here we have a PLC CPU. Siemens PLC CPU is here. All right. Then the connection method are also here too. You remember that I also made mention of how to use sensor with a relay, that you will learn how to use sensor with a relay system. So if you watch how this one work, once this one get activated, this one will get activated as well. Okay, this sensor has in this relay. This sensor is responsible for activating this relay. And this relay now is responsible for shutting down this and activating this, because this sensor only has three cables. This particular proximity sensor has only three cables. Two of the cable is the input signal to get this time the sensor energized. The other third cable is the cable to activate this relay. And once this relay is energized, with this relay has multiple circuits to work with. It can be 4-circuit relay, 3-circuit relay, depending on your configuration. So the whole of those circuits coming from the relay can energize multiple items and de-energize multiple items. All right. So don't be confused when I said the sensor shut down this, activate this, and you are aware that sensor has only three cables. You'll be surprised why only one cable will activate this and deactivate it. No, sensor is activating a relay. The relay is responsible to shut down and put on so many circuits, so many signals, so many items. Okay, so I can have a sensor, I can have a relay that has 4 circuits. So in that case, I'm going to activate 4 items or 4 equipment at the same time, or deactivate them at the same time, depending on the sensing instruction that is coming from my sensor. Okay, this is the more reason why I said before I teach you automation, I will make you familiarize with the component that you're going to be using, your field instrument and your field components. Once you understand their function, understand their configuration, now integrating them in your design will not be a problem. Okay, all right. Okay, so now since we are done with this, so let's do away with this video. Let's take away the video. Then we go back to our programming environment. So this is our Siemens Tier Porter software where we're going to write the program. Remember the narrative. So what we are going to do, we're going to call off the narrative again and put it aside, put it somewhere here, so that as we program, we're going to work with the description. Let's keep it here, reduce it more. I don't know if you're looking at it clearly. Just hold on. So by the time you register for this course, um, I will start teaching you the component designing, how to understand each component like sensor, switches, relay, contactor, their operation sequence, and how to use them in your design. Their responsibility for every given time. You understand the symbols, you understand their instructions. Once you understand every component instructions, it's very easy for you to now begin to plot them and use them to design whatever thing you feel like. Okay, all right. Now, let me repeat network one. Network one said we should put up a network, a design, a logic such that when the process is being activated, that is to put on, once you put on the logic, then a conveyor is going to get energized. And that same conveyor is going to be latched, meaning that it's going to remain on, but it's not going to remain on indefinite. It's going to remain on waiting for another instruction from another network to commence. Okay, so let's do that now. Okay, I have, sorry, bring it back. Um, okay, remember that this is just an introductory aspect of this our design. You are not expected to digest and understand every bit of my design unless you register the course. I'm doing this for you to